This is the sea that swallowed 1,000 years of ambition. For centuries, no engineer dared to cross it. But in the 21st century, one nation decided the impossible was simply a problem waiting to be solved. On either side of this strait lay two worlds separated by water. Cities bursting with millions of people, but cut off by a journey that once took hours by ferry.
Or a dangerous detour of hundreds of kilometers by road. Trade was slow, growth was strangled. Something had to change.
Before a single pillar could rise from this strait, engineers had to answer a terrifying question. What lies beneath?
Geological secrets were hidden under hundreds of meters of moving water, and every one of them had to be uncovered. But the seabed was only half the puzzle. Beneath the surface, invisible rivers of ocean currents surged with enough force to topple a pillar before it ever stood. Engineers had to measure the sea's every mood, its tides, its storms, its silent power, before they could dare to challenge it.
Water wasn't the only enemy. Beneath the seabed, tectonic fault lines shifted silently, threatening to shatter concrete and steel. Engineers first had to understand the Earth's deepest tremors.
After years of study, the final design emerged, a bridge built to withstand earthquakes, typhoons, and time itself. To support the bridge, engineers built massive artificial islands in the middle of the ocean, creating solid ground where none existed. With the islands complete, giant steel piles were driven deep into the seabed to withstand earthquakes, typhoons, and centuries of tides. Before construction could begin, divers manually prepared the ocean floor for the foundations above. With the seabed now level and clear, it was time to lower a steel caisson the size of a 10-story building into the darkness with millimeter precision. In the deepest waters, engineers sank giant hollow caissons and filled them with concrete to create immovable foundations.
Now came one of the most dangerous jobs. Divers had to permanently anchor the solid bedrock, welding and bolting steel to stone hundreds of meters below the surface in near-zero visibility.
A single flawed weld could compromise the foundation. Every anchor point had to be inspected repeatedly.
Hold on, I'm flagging a reading on bracket 4. Disregard, rescan confirms integrity.
Then came the moment every engineer dreads. A sensor detected a shift in an anchor bracket. It was too small to see, but critical to survival. A dive team had to fix it immediately. Crisis averted, the work continued. Weeks later, the foundation broke through the waterline, and the ocean became a canvas. While the sea gave up its ground, workers inland forged the bridge's skeleton. Raw steel plates were cut, curved, and welded into towering steel bones destined to pierce the clouds.
Built to withstand typhoons and earthquakes, every steel segment was rigorously tested for the smallest flaw.
Certified and ready, the giant segments began their journey. Too massive for roads, too precious for error. Only the sea itself could carry them, aboard barges built specifically to bear their impossible weight. Waiting at the bridge site was one of the most powerful machines ever built, a floating crane capable of lifting thousands of tons, raising these giants from the sea into the sky. Then came the moment engineers had spent years preparing for. The crane's massive hook took the strain.
Stand by for alignment 3, 2.
While one tower climbed toward the sky, beneath the waves the pier columns took shape to support the approach spans. Once again, human hands made it possible.
Once the concrete cured, the final underwater connection was made, bolting the steel pier cap to the column, creating a joint that would carry the bridge's weight beneath the waves.
Months into construction, a powerful typhoon approached the strait. The half-built towers faced the force they were built to survive.
Sway sensors are holding within tolerance.
When the storm passed, the towers still stood, untouched and unshaken. Years of engineering had triumphed over nature. Now they could reach their final height. Inside each tower's crown, engineers installed massive steel anchor boxes that would one day hold hundreds of cables supporting the deck below. But a cable needs two ends. Far below, divers prepared massive steel anchorages bolted into bedrock, built to hold every cable against immense forces. With both towers standing, it was finally time to build outward. Segment by segment, the deck began its slow march across open water, supported by cables yet to come.
From the first segment, a rhythm took hold. Day after day, the deck marched outward from Tower 1, reaching farther into open water with balance and precision.
Kilometers away, Tower 2 began the same journey. Two cantilevered decks grew from opposite ends of the strait, racing toward a single meeting point. Before the final closure, every underwater connection had to be checked one last time. Even a millimeter of movement could cause failure. After years of construction, only a single gap remained, a few meters between two decks growing from opposite ends of the strait. Today, that gap would finally close. With the deck complete, it was time for its wings. Hundreds of steel cables were threaded from tower to deck, allowing the bridge to flex and endure. With the cables supporting the deck, engineers finally poured the road surface, concrete laid with precision to endure a century of traffic. Now came the finishing touches: asphalt, guardrails, and road markings, transforming engineering into a bridge ready for the world. Before the bridge could open, every weld, bolt, and seam was inspected one last time. Everything was verified. This was the ultimate test, a final verification. From seabed to summit, if every link held true, the bridge was ready to bear history. Certification wasn't enough. Engineers lined up hundreds of loaded trucks and sent them across, watching every sensor for the slightest sign of strain. Trucks proved the bridge could carry weight. Using embedded sensors, engineers simulated a maximum earthquake and typhoon, testing the bridge's digital twin under extreme conditions. With its strength proven, the bridge needed its nervous system, thousands of lights, sensors, and safety systems to watch over it and welcome the world after dark. After years of steel, concrete, and calculation, the final steps were simple: a last coat of paint, signage, and the finishing touches that made the bridge ready for the world. On the eve of opening day, the bridge stood complete. Tomorrow, the world would cross. Tonight, it belonged to the stars, the sea, and its builders. Then morning came. What was once empty ocean now carried a bridge that redefined what engineering could achieve.
Word of the bridge had spread worldwide. As the sun rose on opening day, crowds gathered on both shores, eager to witness history. After years of storms, sacrifice, and impossible engineering, this was the moment it all led to. With a single cut, the bridge would officially belong to the world.
Then, for the first time, vehicles crossed waters once thought impossible. Years of sacrifice and engineering now carried travelers in minutes. When the celebrations faded, the numbers told their own story. A bridge that didn't just cross a strait, but rewrote the limits of what humanity could achieve. In the days that followed, the bridge became a destination, bringing families, photographers, and a new sense of national pride. But a bridge this ambitious is never truly finished. Every day, engineers monitor its cables, joints, and anchors to keep it standing strong for a century and beyond.
What began as an empty, hostile ocean became one of humanity's greatest engineering achievements, built by the courage of divers, the skill of engineers,
and the belief that the impossible could be achieved. More than a bridge, it stands as proof of what humanity can accomplish.